Hey guys, Tiny Maths here, back with another video, helping you on your maths journey one step at a time. In our last lesson, linked in the description, we learned how to find the highest common factor of two numbers using prime factorization. Knowing the highest common factor of two numbers is very useful when you are asked to simplify fractions, sometimes called reducing fractions. If you can find the highest common factor of the numerator and denominator of a fraction, you can divide both by the highest common factor, and that will give you the fraction reduced to its simplest form. It is quite common for students to reduce a fraction in the following manner. Take the fraction 25 over 48. To reduce it, we need to find the highest common factor of 25 and 48. So we can use it to divide both numbers. The factors of 25 are 1, 5 and 25, and the factors of 48 are 1, 2, 3, 4, 6, 8, 12, 16, 24 and 48. What is the highest common factor? Well, the only number they share is 1, and if you divide any number by 1, it doesn't change. 25 divided by 1 equals 25, and 48 divided by 1 equals 48. Dividing by 1 will not reduce the fraction. Now these two numbers share no other factors, so there's no common factor that we can use to divide top and bottom. The fraction cannot be reduced, so it is already in its simplest form. Actually, this is the purpose of reducing or simplifying a fraction. It is to get the fraction to numerators and denominators that cannot be reduced any further. But what if you had large numbers in your fraction? If, for example, your fraction was 1120 over 1750, using this method you would need to find all the factors of numerator and denominator. Good luck finding those and writing them out if you're taking a test or exam. Not only will it take a lot of time, but you could easily make a mistake. Thankfully, there's a relatively pain-free way of doing this. You can find the highest common factor using prime factorization. If you don't know how to do that yet, I've made a video showing you how to do this. So follow the link in the description and watch the video. It'll help you make sense of today's lesson. And before I forget, why don't you smash the subscribe button and like the video. Hopefully the algorithm will promote Tiny Maths videos to more students needing maths help. Now let's look again at our fraction 25 over 48 and use prime factorization to find the highest common factor of numerator and denominator. We'll use a factor tree for this. Starting with the numerator 25, we divide by the smallest possible prime number. Neither 2 nor 3 divide 25, but 5 does, so we get that 25 equals 5 times 5. We can't factorize 5 any further, so 25 is 5 times 5 in prime factorization format. Now let's work on the denominator 48. 48 equals 2 times 24. 24 isn't prime, so we can factorize it. 24 equals 2 times 12. We can factorize 12. 12 equals 2 times 6. And finally we factorize 6 to get 6 equals 2 times 3. Now we can factorize no further. We multiply all of the factors, all of the prime factors that resulted, and that gives us that 48 equals 2 times 2 times 2 times 2 times 3. We now look for pairs of numbers across these two prime factorizations. Well, 48 and 25 share no factors at all. There are no 5's in the prime factorization of 48, and there is no 2 nor 3 in the prime factorization of 25. They have no common factors, so there are no pairs for us to make between the factorizations. 25 and 48 have no common factor, so 25 over 48 cannot be reduced further, which is what we saw with the more common method. What about the much harder fraction 1120 over 1750? Let's use prime factorization to find the highest common factor. Let's start with 1750. 1750 equals 2 times 875. Now 2 doesn't divide 875 and neither does 3, but 5 does. 875 equals 5 times 175. Since 5 is prime, we can't factorize it further, but we can move to 175. 5 divides 175 and we get 175 equals 5 times 35. 5 also divides 35 and we get 35 equals 5 times 7. Both 5 and 7 are primes, so we stop there. Now we just multiply all the primes we encountered, and that gives us 2 times 5 times 5 times 5 times 7 equals 1750. Now let's do the numerator. 1120 equals 2 times 560. 2 goes into 560, giving 560 equals 2 times 280. Again, 2 goes into 280, so 280 equals 2 times 140. We can do this again to get 140 equals 2 times 70. We can divide by 2 again to get 70 equals 2 times 35. Now, neither 2 nor 3 go into 35, but 5 does. 35 equals 5 times 7. And now we multiply the resulting prime factors and get 2 times 2 times 2 times 2 times 2 times 5 times 7 equals 1120. Now we simply look for pairs of numbers across the two prime factorizations. There is one pair of 2's, one pair of 5's, and one pair of 7's. We ignore one of each pair and multiply for the highest common factor. So that's 2 times 5 times 7, which equals 70. That's our highest common factor. Now we can divide the numerator and denominator of our fraction by 70, and we get 1120 divided by 70 equals 16, and 1750 divided by 70 equals 25. So 1120 over 1750 is reduced to 16 over 25. No need to write out long lists of numbers and look for the highest common factor. Just to demonstrate that we can't reduce this fraction further, look at the factors of the numerators and denominators using the first method. The factors of 16 are 1, 2, 4, 8 and 16, and the factors of 25 are 1, 5 and 25. They share no factors except 1, and since divided by 1 makes no difference, 16 over 25 must be in its simplest form. So that's how to find the highest common factor of numerator and denominator using prime factorization, so you can simplify fractions. Don't forget to check my previous video, which gives a detailed breakdown of how prime factorization works. I'll link to it here on screen. And don't forget to like the video and subscribe to the channel and hit the notification bell for more high school level maths content. Well, that's the end of our series on prime numbers. I've linked to the other 4 lessons in the description. So that's it for now. Take care. Until the next video.